All right, everybody. Well, it's about 11 o'clock, so we're going to go ahead and kick this thing off. We have about 30 minutes here. Fusion 360 and Inventor is the topic we're going to be discussing. I'm going to go through a brief outline here. If you guys, just so you know, if you have any questions, feel free to throw them in the questions panel. I have Nick Narzinski from D3 also with me as a panelist, and he'll be able to answer any questions you have during the presentation. Also, at the end of the presentation, after our 30 minutes, we'll have some time for some additional Q&A. So if you have any questions at that time, feel free to send those in also. All right, so today our topic is Fusion 360 and Inventor. Now, a lot of you may have registered when the title initially was Fusion 360 versus Inventor. Getting a lot of questions about that. The topic of this webinar was not really pitting one against the other. Our focus really was seeing what the differences are for a customer trying to see which tool is right for them. Not only that, but seeing how they can even work together. So these questions you might have had: what makes it different? What benefits does Fusion have? Or for that matter, what benefits does Inventor have over Fusion, right? The real question is it Fusion right for you? Is Inventor right for you? Are they both right for you? So in this webinar, we have a few topics we're going to cover. Just a quick footnote here, Fusion has a very aggressive release cycle. So the info that I'm presenting today is current right now. It may not be current tomorrow. There's another update coming very soon, and we'll see what new features we get at that time. With that being said, our main topics are going to be what Inventor has that Fusion doesn't, what Fusion has that Inventor doesn't, and really using Inventor and Fusion together, which is right for a lot of people. Additionally, I'd like to briefly hit on some things that are coming up soon in future releases. So I'm going to go through some of this data. We will jump out and actually do some live stuff inside of both programs. All right. This is the first topic I wanted to hit, is using Inventor and Fusion 360. This could just as easily be using SOLIDWORKS in Fusion or CATIA in Fusion, Pro-E in Fusion. Really, the benefits are the same with traditional CAD and Fusion together. So this is kind of currently where I see the two different types of programs. Traditional CAD is very good at heavy design. So we have things, and the terminology here is from Inventor, but most of these programs have equivalent tools. Design accelerators like frame generator or bolted connections that allow you to automatically generate files, automatically make calculations. Traditional CAD is very good at that. It's been being developed for many years now into those software. Wire harness, tube and pipe, again, these are environments in Inventor, but they allow you to automate the design process a little bit. Instead of modeling each and every single little thing, you basically tell Inventor where you want the tube and pipe to start and end, what type of fittings and connections, and it generates and grabs components for you. Another topic, configurations, iParts, iAssemblies, even iLogic, and advanced in drawing environment. So tools like that are going to be very good in traditional CAD. Fusion 360 and traditional CAD tools all do very good at basic modeling, but these tools are really where those are going to shine. And Fusion 360 is, we really see the cloud tools being the main focus here. So no matter what software you're using, you can load your models into Fusion 360 to get access to all of these tools. Cloud simulation, using the Nastran solvers, cloud rendering and animations. With Fusion Team, which is kind of like a website, a team hub for your team, you can have cloud access to data and even collaboration with outside people. Integrated CAM, freeform, parametric modeling, surface modeling, direct editing, mesh editing, all inside of one environment in Fusion. So those are some great advantages to Fusion 360. Now, I'm going to jump back to this first topic here, what Inventor has, and we're actually going to take a look at some of these tools inside of Inventor. And these would be the benefits of using a tool like Inventor. So a lot of the same things here, design accelerators like frame generator. You automatically generate the design. Bolted connection, it's a very simple tool to create bolted connections, but it also includes things like calculators for forces and helping you to design. Tube and pipe and wire harness, configurations. So you have the same type of design with many different sizes and parts. Traditional CAD and specifically Inventor, since that's the title of this webinar, Inventor is going to be very good at that kind of stuff, whereas you won't find it all inside of Fusion. Advanced drawing environment. Fusion is developing their drawing environment. That's on the roadmap for the near-term development. The drawing environment will continue improving, but right now it's pretty light. If you need to do things like positional representations, design with moving parts, and you want to document those, you can do that in Inventor today. Fusion not really have the same tools as Inventor does in that case. Or view representations. Maybe you want to filter a view out and filter your bill of materials off of that. So those types of tools are going to be great in Inventor. What I would like to do is pop over to Inventor and just take a look at some of these. First thing I want to look at is the frame generator. So I just have a simple skeleton here. I'm going to go to the Design tab where our design accelerators live, and I'm going to insert a frame. So we'll start with a 4-inch, and we'll just grab all these pieces. And I'll go ahead and generate those. And then while I'm at it, I'm going to add a smaller 3-inch frame around these middle pieces. All right, so again, this is in Inventor. This tool makes it very easy to design something like this. We've got our layout piece. Let's turn it off. Do some quick mitering on this. Right, so these tools are productivity focused. We basically lay out the design and let Inventor generate the parts for us. Do some quick end treatments and connections. I could continue and trim all these frame pieces off and complete this design, but I don't want to get that deep. We're just kind of looking at an overview here. This is a very quick way to do this. Not only that, if I go to the bill of materials for the assembly, let's go ahead and enable that view. We've got full data quantity needed of each part, calculated by length, and we can do stuff like this. Let's go to the layout, and maybe we decided that our 5-foot table needs to go down to 4 feet. Oh, not 4 inches, 4 feet. When I return to the assembly environment, that frame is going to update for me. So again, this is just one simple example, but frame generator. This is one of the tools that Inventor is great at today. So, if you're using Inventor and Fusion together, you could totally do your design in Inventor and then push it into Fusion for other reasons. But if you're looking at the two of them and you do this type of thing, Inventor's better at it today. I want to look at the bolted connection next. That was also in our design accelerator. So with the bolted connection, I'm basically just going to tell Inventor where I want this small connection, and I've actually already set up the connection that I'm going to use over and over, so that I don't have to go through the libraries and pick the components. And we'll go ahead and use the pattern that I made in the part file. So after some initial setup, it's that quick. I've now generated 4 bolted connections. My bill of materials now contains all of the quantities and items needed for those. Not only generating these, but if I needed to, I could go to this calculation tab. I could put in some sources, run some calculations, and make sure that this connection is going to be sufficient. If not, I may want to switch to a different size diameter for my connection, or add more bolts. Right, so this is a great tool, this type of complex, heavy design. Great inside of Inventor. The last thing that I want to look at there is just the configurations, the iParts. So in Inventor, we basically have a table. We can set up multiple size or parameter options, even have components suppressing and unsuppressing as needed. This is a great tool inside of Inventor. So here we have our family table. We can just add new rows when we need additional sizes, go through and change our properties or parameters inside of that model. Additionally, when we go to use that part in the future now, we get to pick which version of it we would like to place in our assembly. Okay, so again, those are some of the benefits. Let me jump back into our presentation here. Let's take a look at Fusion 360. We have some really cool new stuff in here. So on Fusion 360, we talked about the cloud simulation. These are the Nastran solvers. So some very advanced simulation you can do inside of Fusion 360. Whether your model was created in Fusion 360 or Inventor or SolidWorks or anything, you can use these solvers, these tools, inside of Fusion simply by referencing your model in. We have cloud rendering. So this tool is actually, I'm really liking the cloud rendering in Fusion. We have several customers who previously used Showcase, you may have heard, was recently discontinued, and several of them are moving to Fusion for their rendering needs. It's quick and easy. There's a huge material library. It's just drag and drop materials. Way simpler than some of the full-time, rendering applications like 3ds Max. So for basic cloud rendering, it's awesome. We have collaboration tools inside of Fusion through Fusion Team, which again is that hub, that hosted website where all of your data can go securely and be shared out. So with the collaboration tools, you can send a link of your model. You can start a live review where somebody that opens your link is actually watching you navigate the model through a browser. They don't even need any software to view or collaborate with you. Additionally, you can invite them to your team where they have full access to, per project to be able to collaborate and see updates in real time. We have cloud CAM libraries. And full CAM tools right inside of Fusion. So if your current solution does not have CAM built in, that is another great use of Fusion alongside what you're already using. Also multiple integrated modeling techniques. So we could do freeform modeling, sculpting, solid modeling, parametric modeling, mesh modeling. All of it is inside of Fusion. You do not have to go out or upload files to another program to do any of those modeling techniques. All right, so I'm going to pull open Fusion now and take a look at some stuff inside of Fusion. Some of these benefits. Here just have a simple model of a reciprocating saw. Fusion is a very intuitive, very nice and complete modeling program. So we got this full like assembly structure built in here. We have motion, as you can see. We can even, this is kind of cool, we can animate the model. So have you ever started the drive tool in Inventor just to drive a joint and see how the model acts as you zoom around and look at it? You know, great tool here inside of Fusion. I want to look at the, I'm going to jump over to some simulation. These are kind of cool. So first of all, there you go. I'm going to come here. I want to look at just the main simulation environment. So with any file that you have open, part assembly, whatever, in Fusion you can switch between the environments by just clicking here in the environment area. And when I go to the simulation environment, I get simulation tools. Also, the ability to start a new study here. So this is really pretty advanced simulation that we have available. We have just, you know, static stress. We have structural buckling, modal and thermal analyses available, and then as well as some previews, which are previews right now, but will be added in future versions as full releases. Event simulation, nonlinear static stress, and shaped optimization, which is really cool for additive manufacturing approaches especially. So I'm not going to run my own simulation here, but I will say one of the really cool things about the simulation in Fusion is that you can do cloud solves. So have you ever started a simulation in your software and then you don't start it till 5 o'clock because it's got to run all night? With Fusion, you can run a simulation in the cloud and continue working. In fact, you can run parallel simulations. So you may simulate 6 different events while you go through and continue modifying or working on another model. And so that's awesome. I want to look at some of these cool, more advanced simulations. I don't know why these event simulations are really cool to me. So we have an axe here going through a pile of wood pieces. This is a very advanced simulation. You can't do this kind of thing inside of Inventor. So we're actually analyzing separation and all kinds of stuff. This one was really cool. Also, this is a projectile impact, and there is a full model, but we've sliced it in half so you can better see what's going on as the projectile hits the block and shoots through it. So pretty awesome stuff there. Of course, you have the standard analyses too, just stresses and deformation and safety factors, and all of that's available inside of Fusion. Go back to Fusion. Reciprocating saw, I want to look at the rendering environment. So it's very easy to import a model in any format into Fusion, step files. You can do multi-body, part file from Inventor or whatever you want. And the rendering environment gives us Autodesk's huge library, as well as the you can create a cloud library of your own customized appearances to use. Once they've been applied, I'm just going to start a local render here just to show you kind of how the local, you can do an in-canvas local render, and over time it will kind of refine and get better and better. But if you don't want to wait for that, we also have the cloud rendering available. So with your cloud credits, you can submit to the cloud renderer any number of Let's go to print. Let's do an 8.4 megapixel. Right, so you can kind of play with the settings and see how many credits it's going to take to render that. Also, you can do turntables, some videos and things. So this is awesome if you have a couple huge renders you want to calculate, but again, you don't want to lose the ability to continue working in your product. You can also set up specific views to automatically be cloud rendered every time you update your model. So whenever you hit save, a new version is created, your new renderings will automatically be generated and available to the model, even to people viewing it outside of Fusion. So that's what I want to take a look at next. If you right click, and we have a couple options here: start live review, share public link. Also in the information for this file, we can open the details on the web. So public link literally just gives you a link. You can copy and paste. Anybody, whether they have Fusion or any software, can go to that link and view your model on the web. So I have that open actually in another web window already. This is the same model we're looking at here. Somebody across the globe could be viewing it. Maybe they want to do a section view through the model to see what's inside of it. We have some quick markup tools, so even without the collaboration, or we could do a cloud. Cancel that. I just want to take a quick screenshot of this, save that file with my cloud. So again, this is just general viewing capabilities. We also have the Fusion Team Hub. So if you're using Fusion for this, you want the full collaboration benefits out of it, this Team Hub is what you need. This is pretty cool. We can see full data on this document. If there are any simulations or renderings, those are available also. I can even see that Ryan Johnson right now is editing this file inside of Fusion. We have full version history. Let's go ahead and view it. And I don't want to see the simulation. I would rather see the full design. So I have a design review coming up, but my boss is out of the country for the week, and he needs this to go through really quick. We could do a collaboration just through the web on his own time. So let's say that I need to comment on this guy right here. Go ahead and post that comment. That comment would now be available to anybody viewing this file. They just click on the comment bubble and it takes them to that view. They can easily add their own responses. So for the collaboration, this is a really great benefit of using Fusion along with that Fusion team that we talked about. Yeah, one other thing. So I want to just take 1 or 2 minutes here and look at the freeform is really cool in Fusion. I'm going to skip that for time's sake. I would like to look at the CAM tools. So if you don't have integrated CAM right now, Fusion would be a great solution no matter what software you're using. Again, you can load your models into Fusion. In the future, there will even be a connected desktop where you could be working on the original SolidWorks file. You don't even have to translate it to a Fusion file. So that's pretty cool. Just take a look at this model. Let's go ahead and simulate that. Right. So this is just a quick simulation of the toolpaths and what it's going to do to cut, so you can preview the whole thing. Hopefully it's not really going to get cut that fast. But pretty awesome. You can completely set this up. It can tie to the model and be updated automatically when the model changes. Another great use of Fusion. Okay, so back to the presentation. We have about 5 minutes left. Let me kind of quickly go through some of the stuff that I see coming out in the near future. Sheet metal. You may have noticed I didn't even mention this as a benefit of one over the other. Sheet metal is coming soon to Fusion. The betas are already out. Who knows, we might see it in the next update. I don't know. But sheet metal will be coming soon. This one I'm really excited about. Connected desktop is in the future plans for Fusion. So in other words, you'd have a little folder on your computer that syncs to your Fusion team. So that, for example, the Inventor or SolidWorks or any software user could just save files into that folder. They would automatically be available in Fusion to open and run simulations or renderings or whatever. This one is pretty cool. I can't wait for that to come out. Branching and merging, this is pretty cool. There's a preview for this out already, but it's really cool. Data management kind of versioning tool. You have a main design. You could have multiple designers working in parallel on different iterations of different parts of the design. As needed, you can push or pull data from a branch into the main design. You do not have to completely replace the design. You can pick and choose what you want to pull from each branch. I've been playing around with it a little bit. I'm really kind of excited to see where this one goes. For data management, it's pretty cool. Okay. So in a nutshell, I hope that gave you a good idea of some of the differences between Fusion and Inventor and kind of where they each fit. What makes Fusion so different? My main answer would be the cloud stuff. Benefits, the cloud stuff. Of course, the benefits of Inventor or traditional CAD currently would be the heavy design tools. But I will say Fusion has a 6-week release cycle, so it is very quickly getting up to date and growing in complexity and capability. So is it right for you? That is up to you to decide. Definitely worth keeping an eye on though and seeing where Fusion goes and how it continues to grow. With that, the last thing that I wanted to do before we get to our last Q&A session, D3 just today released or is announcing our Fusion 360 blog. So if you go to our website, we have a blog category, or d3tech.net/blog. The first post is, hello, my name is Fusion 360. So I'm going to pull that over here real quick. D3 blog, here you go. Right? So just our main D3 website, we have a blog category, and this is just kind of our kickoff, our introduction. What is Fusion 360? Why should I care? That is why we're releasing this blog. So we're going to have continual updates just on things that we've noticed and found and where we see tools working or not working. Hopefully that helps you guys out. It is interactive, so feel free to jump in there and post comments on posts. We'll be monitoring it and hopefully getting some good discussions made. So with that, I'm going to conclude the presentation part. I know I see several questions rolling in, so for a moment here I'm going to go ahead and skim through these and see if I can answer any of those. If anybody wants to ask a question online or over the phone, just shoot me a question and let me know. If you don't have any questions, thank you very much for attending, and I hope this was useful. Frederico Gonzalez wants to know if the presentation is being recorded. We are recording it, and we generally do make our webinars available publicly on our website. So just d3tech.net, you should be able to find the recording. And I can also send you a link to it afterwards if you'd like, Federico. Earl has a question on the simulation. We may have already answered this, Earl, but is it better than Inventor? It definitely has more capabilities than the base Inventor simulation. It uses NAS-trained solvers and some pretty advanced simulation tools. Previously, you could have gotten through Simulation Mechanical, but that was also just announced as being discontinued. So I think Fusion is going to be a pretty big tool for the simulation community. Darren Haverstick, does Fusion have an API? Yes, you can actually access the API. Oh, I just realized that Nick has been answering some of these questions too. So. All right, I'm going to take some of these questions offline, and I'll be chatting with you directly. Thanks, everyone.